welcome to episode 6 of Battleships. In the previous episode, we plugged our player's input into our game board object, and we also figured out how to decide when the game was over. In this episode, we're going to take our one-player game of Battleships and make it two-player, so that we have two different people facing off against each other, trying to destroy each other's battleships. In order to do that, we're first going to just add in the concept of a second player and talk about what that will actually involve. Then we're going to have a couple of other different things we have to solve. We're going to have to make sure that we can alternate turns between the different players, and we're going to have to make sure that we can print the correct winner at the end. Let's think about what it means to add a second player. What's going to be complicated about that? Well, we're going to have two game boards. We're going to have two sets of battleships, two sets of shots. We're also going to have to make sure, as we mentioned, that we can alternate between our different players. Some things for the future are we might want a secret way for players to arrange their battleships. Because at the moment, the only way you can arrange battleships is by hard coding them into the program. Or maybe we could write a function that generates them randomly. Either is possible, but in a full game of Battleships, you give players a way to arrange them in a sneaky way to try and outfox their opponent. But that can come later. We're going to need two game boards, as I say, but fortunately, thanks to the way we've arranged our code so far, that's actually very easy. We just initialize two game board objects, and then everything that we've got here, all this logic, just completely applies to the two-player situation as well. Taking a shot on someone's board, that's the same. Checking whether the game is over. I suppose we might want to rename this method to be like all battleships destroyed, something like that. But the logic is still the same. And because we parceled it up and wrapped it up nicely, that will work just as it did before. Same with the render method. We can just pass in a game board and render it, and we'll just switch between the different game boards and the different players that we render. Let's start by just giving ourselves two game boards. And we'll figure out how we're going to alternate between them and give players names and different things like that. We can just copy this. And just give them both the same board for now. And then we'll have to, oops. Good. So we have these two separate game boards. Now, whilst we iterate through this loop, we're going to have to work out how to swap between our players. As always, lots of different ways to do this, but let's start by just using an index. And we'll call it offensive index, which just means the index of the offensive player, so the player who is shooting. So if it's 0, it's the player corresponding to this game board, and if it's 1, it's the player corresponding to this game board. And we'll just flip it between those two as we keep going through the loop. So we can say that the defensive index, this is going to be the following, and we'll talk about what this means. This percent sign, if you haven't seen it before, is the modulo or the remainder sign. So this basically means take the offensive index, add 1 to it, and then give me the remainder when you divide this number by 2. And if you think about it, that's going to mean that if offensive index is 0, defensive index will end up being 1, because it'll be the remainder from 1 divided by 2, which is 1. And if offensive index is 1, we have 1 plus 1, the remainder when you divide 2 by 2 is 0. So defensive index will always be the opposite number to offensive index. And just to prove that, say we have x is 0, if we do x plus 1 modulo 2, that gives us back 1. And if we say that x is 1, then now x plus 1 modulo 2 is 0. And you can play with this operator a bit more. If we do 10 modulo 3, when you divide 10 by 3, you have remainder 1, because 3 times 3 is 9, and so that's 1 remainder over from 10. You can look at this operator more on Google if you are interested in it. This is what we'll do to flip to work out what our defensive index should be. And at the end of this loop, we can do the same thing, except this time, well, we can actually just do it like this. We can just say, okay, the new offensive player, the next time we go through this loop, is actually just the previous defensive player. And so now, as we go through this loop, the defensive player here, this line sets the defensive player is the non-offensive one. And then this is just saying that the offensive player becomes the previous defensive player. This takes care of switching between players. Now we need to take care of switching between the boards, because this will switch this index from 0 to 1, but that doesn't take care of any of the actual logic we want to achieve. So we can now say, let's say that the defensive board is the game boards, and we want to use the defensive index and get the defensive players board. And then we can just change all of these so that we're shooting against the defensive players board. Oops. We'll want to figure this out a little bit. We don't want to just print you win. It'd be nice to print which player wins, but we can come onto that in a second. We'll also want to think about the order in which we render and take shots and things like that, because we'll probably want to show our player the current state of the board before we ask them to take their shot. But again, these are all things we can figure out. For now, let's just see if this works. So I want to shoot at 1-1. I want to shoot at 1-0. That's interesting. So I expected this should have just had a single shot there, because this shot here should have been taken on a separate board. So there's something funny going on here. First, let's make sure that all of this stuff is actually working. So let's print the defensive index and the offensive index. 1 and 0. Yep, that's correct. 1 and 0. Ah, okay. So apparently we're not switching over the offensive and defensive players. Wonder why that might be. Let's see if we're getting down to here. Once we get to the bottom of our function, I want to shoot at 1-1. Okay, it's really not doing this switch over at all. Oh, I just typoed this. There we go. 1101. Okay, I believe that's actually correct. We can delete those to make it easier. There we go. So it was 10, then it swapped around to 01. And the problem was I just typoed this variable name. So now if I shoot at 10, there we go. That's what we expected. Let's just play. I want to shoot at 1. Expected that the game would have been over. We have too many battleships. Let's just, again, test it out with a single battleship, see how that works. Shoot at 0, 1, 1, 0. Oops. Again, it would be nice if we caught this error and asked them, oh, that's not valid, please try again, something like that. That's weird. So it thinks that I've won. I know what that is. That's quite interesting. The problem is, we have passed in the same battleships, like the exact same object in memory to both game boards. So that means it's not just that these battleships are in the same place, it's these are physically the same battleship objects according to the program. So when this player takes a shot at the battleship and hits it, and then this player takes a shot at the other part of that battleship, the program thinks that battleship has been entirely destroyed because it doesn't have two different copies of the battleship. As far as it's concerned, we're shooting at the exact same battleship. I actually wrote a blog post about this kind of thing, pass by reference. So I'll put this in the comments. This explains a bit more about what's going on. In summary, the way that for now, we can either just initialize two separate sets of battleships, which is certainly what we should do in the future, because we don't want people shooting at the same battleships. But we can also make what's called a copy of them, so that now they're still the same battleships locations, but there are at least two different battleship objects according to the program. And we will need to import the copy module in order to be able to do that. So now I want to shoot at 1, 0 and 1, 1 and then 1, 0. Great. There we go. The game went on as it should have. Well, that's good. We're now successfully swapping between game boards and successfully printing out when someone has won. I'm pretty sure we get to tick some things off for that. Okay, we've done that. Ooh, we've alternated turns as well. That's pretty good. Now we want to print the winner. We want to give our players names. Lots of ways to do this. I feel like I always say that. For now, let's just have a list of player names like this. And this name corresponds to the player who has this board, and this name corresponds to the player who has this board. It feels a little flimsy to me. It's kind of just, it feels like it'd be easy to introduce a bug where for some reason they stopped aligning up with each other. It feels like maybe we want to do something like we could make a player class where that has both a name and it has a reference to the game board that player is responsible for. So that would tie them up together nicely. Something like that, I think, might be where we want to go. But for now, I think let's just keep it a little simple. Let's not add new objects where they're not needed. Let's just use this player name. And we can use this to start doing player names. And then we can just look at the offensive index like that. And we can also say, maybe we want to print the person whose turn it is. Frank, it's your turn. 1, 1, 9, 9. Frank now wants to shoot at 1, 0. And then Frank wins. Brilliant. That's what we wanted. As I say, as we add more and more complexity to our game, maybe we want to combine these and figure out some more classes that we want to use to do that. For now, we'll just leave it and see how things go. That's all we wanted to do this episode. And honestly, now our game basically works. I think now we can get onto some interesting extensions to it. Let's actually make a note of some of the things we could do. Actually, I like this secret way for players to arrange their battleships. We'll talk about the different options you have for that. Let's add in a random AI player who just, instead of asking a human for their input, they just shoot in random places. I'll probably leave this as an exercise for the reader if you want to take this code and figure out how to do this yourself. An intelligent AI that looks at where current ships are and shoots next to them. Because, for example, if you know you've got 2 shots there, you shouldn't really go off and take a shot over here. Instead, it makes a lot more sense to just keep shooting that thing until it's dead. We want a secret way for players to arrange their battleships. We can more detailed and neat announcements. So ways for our game to announce when different things have happened. This will actually be quite interesting, I think. There's an interesting little construct we can use for that. Maybe also more intricate board renderings. I think I've talked about this several times. I really like the idea of printing battleships like this rather than just like that. Because at the moment, if you see this big blob of O's like this, you don't know what they are. Whereas if you saw this, you could see, oh, I see, it's just two battleships next to each other and not like 2 battleships like this or something like that. And these I reckon, since our code is actually laid out pretty nicely already, I think these will actually be quite easy to add. Our code's nice and flexible. All of the different pieces of functionality are, for the most part, pretty well isolated. And that's going to make it quite easy to add in these extra pieces of functionality. We can commit. I'll leave that scratch file there this time because I want to be able to see those things that we said we want to do. This was episode 6, and what did we do? We added 2-player game, and it worked. It was pretty cool. So that was episode 6. There's probably only 1 or 2 episodes more where we'll add some of those cool little extensions that we just talked about. I will see you next time.